Does more money always mean better performance when it comes to computer components? Let's take a tour through some of the most important components of a computer and figure out when you should pay for more RAM capacity, more CPU cores, and more watts on your power supply, or when it might just be a waste of money. Let's start out by talking about RAM. Is it more important to have higher speed or more capacity? While both can affect performance, you should prioritize higher capacity, up to a point. And this kind of intuitively makes sense. RAM is your computer's working memory, where your PC stores data it's currently working on. So more capacity means your computer can work on more at the same time, meaning larger amounts are helpful if you play demanding games, create content, or just like having an ungodly amount of browser tabs open at once. For a general purpose machine, we'd recommend 16 gigabytes of RAM in 2024, while 32 is a safer bet for gamers, streamers, and anyone else that needs extra power. Right now, going higher than 32 gigs typically is only useful for things like intense content creation, such as video editing and animating, or modeling work. On the lower end, you can get away with 8 gigs if your PC is mostly a browsing and typing machine. But regardless, there isn't much point getting more RAM than you'll reasonably use. It's like buying a house with 10 extra rooms when you're living alone. And it's easy to add more RAM later if it turns out you do need extra, or you want to have roommates. But although capacity should be your primary concern, it doesn't mean you should ignore speed and latency completely. For certain games and applications like video editing, rendering, and streaming, it can make a difference, especially depending on exactly what CPU you have. If you'll be doing any kind of heavy lifting with your computer, it's a good idea to check and see how the games and applications you're planning to use interact with different RAM speed and CPU combos, and where the sweet spot is with frequency and timings. AMD Ryzen CPUs in particular have historically been a bit more sensitive to the frequency and timings of your RAM, though this seems to be less true for their 3D V-cache models. Also remember that trying to run RAM rated for very high speeds can actually cause instability. We're talking system crashes, since you're technically overclocking. Regardless, if you're on a budget and choosing between more RAM and faster RAM, remember that too little fast RAM is a lot worse than a sufficient amount of slow RAM. Let's move on and talk about your CPU. Although the clock speed can affect performance in certain games and applications, the raw frequency number of a CPU isn't as important as it used to be. In fact, some CPUs higher in a product stack can have lower frequencies, so that they'll stay within power and heat limits as the manufacturer adds more cores. And because chips are fairly well optimized these days, there's even been less of a focus on overclocking, with many enthusiasts preferring to undervolt their CPUs instead to achieve similar performance while using less power. But one thing that can matter is core count in general. More cores are better than fewer cores, all things being equal, but there are 2 things to consider before you go out and buy the highest core count CPU you can afford. First, just like with RAM, there's no point in buying more cores than your programs are realistically going to take advantage of. Anything more than 6 cores is probably overkill for a strictly gaming PC, while more than 8 probably isn't necessary if you're gaming and streaming. Higher core counts tend to be useful if you're doing work that can be easily parallelized. Video rendering is a good example of this, as the workload scales better in terms of being able to be spread across multiple cores. On the flip side, if you're just using the PC for basic tasks, 4 cores will likely get you by just fine. But here's a second thing you need to consider: architecture. Because plenty of applications, especially games, are significantly affected by single-threaded performance, you can see real differences in reviews when you compare different processor generations, and especially when you compare AMD and Intel. Depending on the workload, a newer CPU with fewer cores can outperform a several-year-old CPU with more cores. Think about it this way: the PlayStation 4 had an 8-core CPU, but you obviously wouldn't expect it to run modern games as well as a current-gen 6-core desktop processor. Also remember that hybrid CPUs are common these days, where some of the cores you're getting might be less powerful efficiency cores or E cores, so check before you buy. We're gonna talk about another component that's very easy to overspend on right after we thank Seasonic. Check out Seasonic's Prime TX 1000 watt power supply. It's a great choice if you're building a high performance system, and it features an 80+ titanium rating, which means less power gets wasted. Plus, it's fully modular and features hybrid fan control and fluid dynamic bearings to reduce fan noise. Best of all is their industry-leading 12-year warranty. Learn more at seasonic.com or through the link below. There was a time when monstrously big power supplies actually made some sense, back when people were running quadruple graphics card setups. But these days, with multi-GPU being virtually dead, there are simply not enough power-hungry components inside the typical high-end PC to justify going out and buying a 1600 watt PSU. So how many watts should you actually be looking for? While more is better in the sense that it'll allow you to install more and more powerful parts in your rig, going with a model rated for too many watts is not only unnecessary, it can actually end up costing you a little bit extra on your power bill each month. Most power supplies are most efficient when they're running at somewhere around 50% load. So for example, for an 800 watt PSU, that would be a 400 watt load. Every model of power supply is different, so peak efficiency may not be at exactly 50%, but the point is, it's more efficient to buy a PSU that gives you some headroom. That being said, that might be cost prohibitive if you have a relatively powerful GPU installed. Let's say you have a gaming rig that draws around 500 watts at load. You may not want to drop a ton of coin on a 1000 watt power supply. In that case, it's fine to get a smaller one rated for 600 or 700 watts as long as you're sure your system won't flirt with that maximum number when you're really pushing it. And although newer ATX 3.0 power supplies can deal with transient spikes in power draw past their rated wattage better than older units could, you still don't want a situation where you're continuously drawing too many watts. And if you do get a lower wattage but still adequate power supply, you may not get peak efficiency, but it won't be too much worse than what you'd see closer to the half load as long as the PSU is good quality. And on that note, as long as the wattage is sufficient, the power supply's build quality is far more important than the raw number of watts. There are cheap power supplies out there that are notoriously unreliable and can even explode on you, literally explode. But well-built ones can last for many years, even if you push them. So read reviews and don't go for bargain units just because the wattage number is what you want. Finally, let's talk about something that's a little harder to put a number on. Your motherboard, which acts as the spine of sorts of your PC in that it connects everything to everything else. It used to be that your choice of motherboard could have a real effect on the performance, as buses that connect different components could operate at different speeds. And the power delivery systems for CPUs were built very differently between models, meaning some motherboards were far better at overclocking, for example, than others. In modern times though, most motherboards tend to have fairly overbuilt CPU power delivery, except on the very low end. And the functionality of the once crucial front side bus has been integrated into the CPU itself. So does it make sense to spend more on a more premium motherboard? The answer should mostly depend on what kinds of features you want. Make sure it has enough slots, headers, and ports to support the components that you'll be installing. And also pay attention to what chipset it is. The chipset is a separate chip responsible for handling much of the data that flows between different parts of your computer. And different chipsets support different numbers of ports. Some even limit what kinds of overclocking you can do. So is there really a point on splurging on one of those super high-end motherboards? Some of them can offer really esoteric features for really extreme overclocking, like with liquid nitrogen or something equally exotic. You might even be able to get support for more bleeding edge standards. But it only really makes sense to go for a motherboard like this if you have parts that you know can use the extra bandwidth. We've even seen high-end boards with built-in water blocks if you're planning to pair them with a custom loop. But the bottom line is that unless you have some hyper-specific use case, it's probably unwise to blow gobs of money on a motherboard. You're gonna need that extra money anyway when you find out how much DLC costs these days. But we're out of time, even though we know that there are other parts where you need to make important buying decisions, such as your storage drive and graphics card. So let us know if you'd like to see a follow-up Is It Worth It video in the future. In the meantime, check out our explainer on RAM timings if you'd like to know more. So thanks for watching, guys. If you like this video, hit like, hit subscribe, and hit us up in the comment section with your suggestions for topics that we should cover in the future.